All right, do you want me to begin then? Okay. All right, so let's see here. Give you my screen. Okay. Now, let me just make sure. I can't see your comments when I'm looking at my PowerPoint. So I'm just going to come back here to the screen and make sure. Did you guys see the PowerPoint full screen there? Just let me know yes or no. Okay. Okay, good. Thank you. All right. I'm going to go back to then. Okay. So I'm going to be talking to you today about global warming. What's the deal? Now, this is our planet. We've all seen these pictures before. And when we think of our planet, we usually picture it this way. Or if you want to see the whole planet, we picture it this way. As a photograph from NASA, where you can see the green and the brown and the blue and the white, but we don't see any evidence of humans on our planet. Now, our planet used to be mostly untouched with humans until there started to be so many of us. Now we have almost 7.5 billion people on this planet. So a more accurate way to look at our planet is not during the day, but rather at night. And when we look at it at night, this is what we see. This is literally a picture of the world at night. All of those lights you see are the lights of our cities and our roads and all the people on the planet. If we zoom in even further on the United States, you can see it in detail. Depending on what city you're in, you might even be able to spot your city and the roads that connect your city to the other ones around it. But that's not where our story begins. Our story doesn't begin with cities and roads. Our story begins with that blob of light up in North Dakota. Now, for those of you who are good at geography, you can probably see that. There's a big blob of light up in North Dakota, and it's not a big city. It doesn't have any big roads going to it. What is it? That blob up in North Dakota is the light, right there, the light of thousands of fracking wells. The impact that we are having on our planet is visible because of our energy choices. So our story really begins with the Industrial Revolution, which is when we figured out how to dig massive amounts of coal and natural gas and also oil out of the ground and burn it. Here in the United States, about a third of our energy is used in industry. Almost a third is used for transportation. And then about 23% is used in our homes, heating and cooling our homes and keeping the lights on. And then the rest of it, about 18%, is used in commercial buildings. Why is this a problem? It's a problem because whenever we burn coal or gas or oil, it produces this gas called carbon dioxide. Now, you can't see it, you can't smell it. What you see coming out of these factory stacks here, these power plant stacks here, is actually steam. You don't see the carbon dioxide. But just because we don't see it doesn't mean that it's not important. We know that we've been producing a lot of carbon dioxide ever since the Industrial Revolution. More and more of it every year. Why do we care about it? We care about it because it's wrapping an extra blanket around our planet. And I have this cute little video to show you. And you can download the video yourself. You can find it on Facebook's Earth page, or you can find it on my website. And it explains in 1 minute why carbon dioxide matters. So our planet has this amazing natural blanket. As this little video explains, whenever we produce carbon dioxide or methane or other heat-trapping gases, they build up in our atmosphere, wrapping an extra blanket around our planet, a blanket that our planet never needed. It's kind of like when I used to stay at my grandma's house when I was little, and she would sneak in the middle of the night and she would put an extra blanket on me. And I'd wake up in the middle of the night going, Grandma, I didn't need that blanket. I was sweating because she put that extra blanket on. That's what we're doing to our planet. By burning coal and gas and oil and putting all that extra heat-trapping gases up in the atmosphere, we're wrapping this extra blanket around our planet, a blanket that it doesn't need. So yes, the climate is changing. It's changing because of carbon dioxide and other heat-trapping gases that we are wrapping around our planet. The next question, though, is, well, isn't this some new science? Here's what might surprise you. What I just said is very old science. We've known that our planet had this natural blanket since Joseph Fourier, he's the guy on the far left-hand side, since Joseph Fourier in the early 1800s. That's almost 200 years that we've known about the natural blanket around our planet. We've known that mining and burning coal, for example, is wrapping an extra blanket around our planet since the second guy, John Tyndall, in the mid-1800s. We've known how hot our planet would get as a result of this extra blanket since the Swedish chemist Arrhenius calculated it in 1890. And this guy, his name really is Guy, this Guy Callendar, a British engineer, was the first person to measure the warming of the planet due to the choices that we humans have made in the 1930s. This is really, really old science. It's been around from Tyndall all the way through Arrhenius up to Callendar. It's been around for almost 200 years. That's how long we've known about this. Now, if you have more science questions, there's this really great website called skepticalscience.com. It answers all of the but what about questions, a few of which I'm going to talk about today. So if you have more questions, this is a great place to go in the future. Here's the top 3 but what about questions, though. And that's what you can imagine this woman is saying. But what about? Here's the first but what about question you always get. I get all the time when you say climate change or global warming. Here it is. It's freezing outside. Where's global warming now? Pretty natural, right? You wake up, you go outside, it's snowing or it's icing or fingers are freezing off, and you think, ha, so much for global warming. Well, here's the thing. They did a little experiment. One time they took a group of people and they divided those people up. They put half of the people in a room that was 73 degrees Fahrenheit, which is kind of normal room temperature. And then they put the other half of the people in the group in a room that was 81 degrees Fahrenheit, which is quite a bit above normal room temperature. So half of the people were feeling nice and normal, and the other half of the people were feeling pretty warm and sweaty. And then they asked these people, do you think that global warming is real or not? Now, the weather was the same for these people. They all lived in the same place. The only difference was they were sitting in a room. One room was normal and one room was warm. What do you think happened? Yep. The people in the warm room, more of them said, yes, global warming must be real, even though they knew it was just the temperature of the room. And then in the cooler room, less people said that global warming was real because they didn't feel hot. Isn't that crazy? So our opinions are so often controlled by how we're feeling at the time, rather than what we know to be true. The reality is that if you look at the world, and this is looking at the world last winter, we had record cold over the eastern United States and Canada. I don't know if anybody remembers last winter, but there in February, it was really cold. It was about almost 30 degrees Fahrenheit or 15 degrees Celsius colder than average. But you know what? At the same time, there was record heat. It was 30 degrees Fahrenheit or 15 or more degrees Celsius warmer than average up in the Arctic. So we can't count on our personal experience to determine whether climate is changing, whether global warming is real or not. Otherwise, if we just depended on our personal experience, we could come up with all kinds of other faulty information. Like, for example, if you were standing at one end of the Titanic and you said, this ship can't be sinking, my end just went 200 feet up in the air. You see what I mean? You need to look at the big picture when we're asking if climate is changing. So when we look at the big picture, we're not looking at weather. Weather is what happens in a certain place at a certain time. Weather means it's cold outside, or it's snowing, or it's raining, or it's hot. Weather is like a single tree. Climate is like the forest. Climate is the average of every day all around the world for 20 to 30 years. So if you ask me how tall is one tree, I'd say, well, I don't know. It could be a little tree. It could be a big tree. I have no clue how tall it is. But if you ask me what's the average height of a whole forest of Douglas firs, that would be a lot easier question to answer because we're looking at a big group of days, a big group of trees, not a single tree. So when we look at it, what do we see? Well, if you turn on the news, you hear a lot of people saying, oh no, that global warming thing, well, if you only pick a few years, you might say, that doesn't look like it's going up that steeply. But hang on a second, there's a lot more years that we're missing here. And when we fill in those years, and then when we look at the fact that 2014 was the warmest year on record, but then actually 2015 is now the warmest year on record, we say no. Next year could be colder or warmer than this year. We could have snow in the winter. We could still have a cold snap. We could still have freezing days. But over climate timescales of 20 to 30 years, it's getting warmer and warmer. So it's freezing outside. Is global warming real? Yes. You can have a freezing day and you can have global warming at the same time. It isn't just about temperature though, and that's why we often call it climate change rather than global warming. Global warming is, if you remember the very first slide I showed you, global warming is the temperature of the planet increasing because we're wrapping this extra blanket around it. But that extra blanket is having all kinds of impacts on people and places around the world. Up in the Arctic, there's almost 300 Native American villages that are built on ground that used to be permanently frozen. And now, as the Arctic warms twice as fast as the rest of the United States, as the Arctic warms, the ground under people's homes is crumbling and falling into the ocean. In Australia, on the right here, in Australia, they had a heat wave so severe 3 years ago that they had to add a new color to their temperature map. That light purple color in the middle is 54 degrees Celsius or 129 Fahrenheit. We're also seeing that hurricanes are getting stronger because they suck up all their energy from warm ocean water. So as the oceans get warmer, they give more energy to our hurricanes, and our hurricanes are getting stronger. And this is crazy, but it's true. In some places where it's still cold enough to snow in the winter, like the East Coast, for example, of the United States and all over Canada, we're actually seeing heavier snowstorms because as the planet warms, more water evaporates out of the oceans and lakes and rivers. And so the water vapor is sitting up there in the atmosphere. And when the storm comes along, there's more water vapor for it to pick up and dump on us. And if it's below freezing, it falls as snow. When we look around the entire world, it isn't just about the average temperature of the planet. We see, and this is a crazy number, we see 26,500 indicators of a warming planet. Whether it's the trees flowering weeks earlier in our backyard, whether it's bugs or birds or insects that we've never seen here before because it used to be too cold, whether it's glaciers melting or sea level rising, all around the world we see evidence of a changing climate because of the extra blanket that we're wrapping around our planet. So is climate changing? Yes. Even though it's still cold in winter, the planet is warming. Now, the second biggest myth I often get is, but climate's changed before. Well, of course it has. If you've seen the Ice Age movies, you know that climate has changed before. It's been colder, it's been warmer. But we know that we can look at those things and we can see if they're causing our climate to change right now. So let's look at the sun. We get most of our energy from the sun. We get a little bit from the core of the earth, but most of it comes from the sun. So if our planet were getting warmer because of the sun's energy, does that mean that we'd be getting more energy from the sun or less? Not a trick question. If the planet were getting warmer, it would mean that we'd have to be getting more energy from the sun, right? So we can look at the temperature of the Earth. Here's the temperature of the Earth over the last 150 years. And then we can look at energy from the sun. And here's what we see. Actually, energy from the sun was going up until the 1970s, but since the 1970s, it's been going down. So if our planet were being controlled by the sun right now, if our temperature were being controlled by the sun, we'd be getting cooler, not warmer. So it can't be the sun. Well, what about natural cycles like El Nino? We have a big El Nino this year. I don't know if you've heard about it. When it's an El Nino, we tend to get crazy weather many places around the world. Some places are hotter, some are colder than normal, some are wetter, some are drier. So you might say, well, isn't it just an El Nino causing us to change? But here's what we have to understand. All of these natural cycles like El Nino do, they just move heat around the Earth system. They move it around like a teeter-totter, into the ocean, back into the atmosphere, back into the ocean, back into the atmosphere. So if our atmosphere, if the air temperature getting warmer because of a natural cycle, that heat would have to be coming from somewhere. And there's only one place it could be coming from, right? The ocean. So let's look not at the temperature of the planet, let's look at the heat content of the planet. Because if the heat content of the atmosphere is going up and the heat content of the ocean is going down, then we know that that's what's causing our warming, right? Let's look. Oops, no. What we're looking at here, the green is the change in the heat content, not just the atmosphere, but land and the ice or cryosphere all put together. The blue is the increased heat going into the ocean. Did you know that 20 times more heat from global warming is going into the ocean than is going into the atmosphere and land and ice all put together? It can't be a natural cycle. The entire planet's warming. It's not just going back and forth like a seesaw or a teeter-totter. There's one more reason, though, that climate has changed in the past. And if you've seen the ice ages, you know why. In the past, we have had changes. We have had these big ice sheets covering large parts of the world. And we know that those ice sheets disappeared when a squirrel went looking for a nut and broke off a piece of the ice and the whole thing just started to crumble, right? Well, that's not the real scientific answer. The real reason that we have ice ages and warm interglacial periods like we're in right now is because the Earth's orbit changes. Over time, it becomes more circular and then it becomes more elliptical. Also, over time, the axis of rotation changes, just like a top. If you ever spin a top, you'll notice that the axis of rotation of the top changes as it spins. What this does is it changes the way that sunlight falls on the Earth. And that causes our ice ages, and it also causes the warm periods like we're in today. So here's the question, right? Is the warm period we're in today just warming? Are we just continuing to get warmer and warmer because we're coming out of the last ice age? The answer again is no. If you look at the temperature of the planet, the red is our temperature and the black is our carbon dioxide, which again is our heat trapping blanket. The temperature of the planet was doing what for the last 6,000 years? It was going down because the warming after the last ice age peaked. It reached its maximum, its highest, about 8,000 years ago. Since then, we were gradually, slowly heading into the next ice age. Until when? Until the Industrial Revolution. So all of our natural suspects have an alibi. It can't be the sun because we'd be getting cooler, not warmer. It can't be natural cycles because the whole planet's warming. It isn't just the atmosphere and ocean doing a teeter-totter thing. And it can't be the ice age cycles because the next thing on that calendar was another ice age. Not now, not tomorrow, in thousands of years, but it was going to be another ice age until humans stepped in. So why is climate changing? For the first time in the history of this planet, it's us. Here's the third myth now. Ready? The third myth is, why do we care about climate change? Because if you ask people what is the number one picture that pops into your head whenever anybody says global warming or climate change, 9 out of 10 people would say this, the polar bear, right? And it's true. The polar bear is endangered as a result of climate change. Polar bears only eat when they're out on the sea ice. That's the only place they hunt. And the sea ice is coming in so late in the year now, and it's leaving so early that the polar bears only have a few months per year now where they can eat. So they're starting to starve to death because they can't get to their food. That's happening because the ice is melting because of climate change. But why do we care about a changing climate? As humans, we care about it because we're used to, our weather going up and down. We're used to having, hot days and cold days and wet and dry. We're used to our weather kind of looking like this. But what we're also used to is the assumption that it all averages out. We use this assumption when we build our houses, when we figure out how big an air conditioner we need or a furnace, when we build our cities, when we build our transportation, our highways. Everything we build assumes that our climate is stable. What happens if it's no longer stable? And what happens even worse if it's getting more and more variable? Where I live in Texas, this is a picture of where I live in Lubbock. I'm here at the University of Texas Tech right now. We're very flat here, and we have a lot of very straight roads. In fact, part of the interstate highway going north from Lubbock to Amarillo is so straight that you could get a fair ways up that highway driving only looking in the rearview mirror. In other words, only looking backwards where you used to be, because the road is that straight. But just before you get to the next town, there's this huge curve on the road, and this is a picture of the curve. Not only that, but at the side of the curve, there are these row of concrete silos. Can you see them in the picture? What happens if you're driving along the road, looking in your rear view mirror, and you get to that curve? You're going off the road, because the future is different than the past. In the same way, as humans, if we now plan for the future, assuming a stable climate of the past, it's like driving down the road looking in the rearview mirror. Climate is changing, and we won't be prepared for it if we don't look ahead instead of looking backwards. Now, the polar bears can't do that. All they can do is work with what they have. And so there's this fantastic organization called Polar Bears International. They put radio collars on the bears, and you can go to their website. This is a picture from their website, and you can track the bears that they have collars on. And during bear season, which is in the fall up until December, they have a tundra buggy out on the slopes. And I think I actually have a picture. There we go. There's a tundra buggy. They have these tundra buggies out on the slopes, and they have a camera where you can get online anytime, including in your class, and you can actually watch the polar bears. I'll show you a picture. That's me with the tundra buggy. Here's a picture on the left. Here's a picture of one of the polar bear scientists, Steve Armstrong. He's sticking his head out the window of the polar bear, of the tundra buggy, talking to the polar bear. He's literally talking to the polar bear, and the polar bear looked like he was listening. You see that big white thing right above Steve's head? That's the polar bear camera. So every fall, you can go online to Polar Bears International, and you can actually see the polar bears wandering around waiting for the sea ice to come in. I got to go up with my son, Gavin, who's 8 years old, and that's a picture of Gavin on the right in his Minecraft hoodie, and he's looking over the edge of the tundra buggy at a little baby polar bear. They were looking at each other, and the polar bear was probably thinking, what's he doing up there? Because they're really smart. It isn't just about the polar bear, though. All kinds of animals around the world are endangered because of climate change. As this shows us, just a couple of examples, warmer ocean temperatures are killing off the food for North American right whales. There's only 350 of them left. Loggerhead turtles. As it gets warmer, more female turtles are born and less male turtles. If they don't have enough male turtles, they can't have babies, and they'll become endangered. Over the last 50 years, Antarctic penguins have been disappearing because of melting sea ice in Antarctica. And polar bears are 10% thinner now than they were 30 years ago because they're starving for longer every year. All around the world, there's over 1,400 species that are endangered by climate change. But here's the thing. After the polar bear, what we have to recognize is we are one of the most vulnerable species. Why is that? It's because there's so many of us, and we've built so many of our cities right beside sea level. What happens if sea level goes up 3 feet or a meter? 2/3 of the world's biggest cities are within that zone. What happens if you can't grow crops anymore to feed your family? If you live in Africa or Southeast Asia, that might mean the difference between survival and starving. I'm going to tell you a story about a little town called Kivalina up in the Arctic. Kivalina is on a little peninsula sticking out into the Chukchi Sea. That peninsula used to be frozen all the time. But as climate warms, the ground it's built on is starting to melt and crumble. And even more, the sea ice is coming later and later in the year. So it used to be when the autumn storms came, they would crash onto the sea ice. But now when the autumn storms come, there's no sea ice and they're crashing right onto the land, as you can see right here. When those storms crash onto the land, they're digging away and eroding all of that loose earth that started to melt. And so even though the villagers try to shore up their coastline, every time a storm comes, it rips all these big things of rocks away. And many of their buildings either have fallen or are teetering on the edge. Here you're actually looking at the school principal looking over the edge to see the latest building that just disappeared. We humans are very vulnerable to a changing climate. Whether it's incredible heat waves like we had in 2011, these types of heat waves are getting stronger and stronger and much more frequent. See how much hotter it was? Over 100 degrees across much of Texas and Oklahoma. The heat wave that we just talked about in Australia, where they had to add a new color to their temperature map. We're also seeing more heavy rain and snow, like I talked about, because in a warmer atmosphere, more water evaporates. And so when a storm comes along, there's more water vapor sitting up there for the storm to pick up and dump on us. And we've seen that happen. This is showing over the past 50 years. This is a flood that we had where I live in Lubbock, Texas. Last September, this is a 6-lane highway that's flooded and underwater right next to our football stadium. At the same time, we've seen stronger droughts because in a warmer atmosphere, again, more water evaporates. That means there's less of it left in the soil and the lakes. Our hurricanes are getting stronger because they feed off our warm ocean water. And remember, we saw 20 times more heat is going into the ocean than into the atmosphere from this extra blanket we're wrapping around our planet. What does that look like? Well, if you live on Long Island and you experienced Superstorm Sandy, it looks like this. If you live in the Philippines, it looks like this. Why do we care about a changing climate? It's not just the polar bear. We care about it because it exacerbates, it makes a lot of the risks we already face today worse. How will people have enough food to eat? How will they have clean water to drink? How will they have a safe place to live if these types of disasters are increasing and increasing? There's one more thing though. It isn't just about what matters to us. If we look at where all that carbon is coming from, and then we look at who is bearing the impacts of this problem, the maps are pretty much exactly the opposite, aren't they? Here's where most of the carbon has come from over the past 100 years, and here's who's bearing the brunt of the impacts. People who already live off about $1 or $2 a day. What happens if the price of food doubles? They go hungry. In Florida, this century, by the end of the century, we could lose half of the Everglades and most of the Florida Keys. In Bangladesh, they could lose the place where they grow half of their rice and 18 million people live. In the United States, we're going to be losing Glacier National Park. There will be no longer any glaciers in it. They'll have to rename it. But around the world, there's 1 billion people who depend on glaciers for their water supply. This is the glacier that supplies the city of Lima, Peru, with 8 million people. Here's what it used to look like in 1978, and here's what it looks like in 2004. A few years after that, it ran out. So they had to build a desalination plant to desalinate water from the ocean, but it costs a lot more to do that than to get free water from glaciers, and not everybody has the money. If you want to know more about the impacts of climate change, watch The Years of Living Dangerously. It really puts a human face, a real face on the impacts that we're seeing around the world. We care about climate change not just because it affects me and my family. We also care about it because it affects especially people who don't have the resources we do. And it's just not fair. They never made the problem, yet they're suffering the biggest impact. So last question. What can we do? Because we know that the amount of climate change that we're going to see in the future, and this is showing how the global temperature might continue to increase, the amount of change we see in the future depends on our choices. Are we going to keep on using fossil fuels like coal and gas and oil? If so, we're going to see a lot bigger warming. Are we going to be able to transition to renewable energy like wind and solar? Then we're going to see a lot less warming. But what can you or I do? Because this is this big global problem. What can we do? Here's a few ideas. First thing we can do, measure our carbon footprint. You can go to this carbon calculator on the Nature Conservancy's website, or you can go to the EPA's carbon calculator too, and you enter all the information about your home. How many people live there, how much you drive, what type of food you eat, and it will tell you what your carbon emissions are. Because how would you know what to reduce if you don't even know what they are, right? Carbon emissions are. Because how would you know what to reduce if you don't even know what they are, right? So measure your carbon footprint. That is the first and the easiest thing we can do. It doesn't even hurt, I promise. Then we can make smart choices to conserve our energy. What are some examples of conserving energy? Well, if you take an old-fashioned incandescent light bulb and you replace it with a brand new LED light bulb, like this one in the picture here, you're going to use about 90% less electricity right there. And if every home in the US replaced just one light bulb, that would be like taking 1 million cars off the road. Isn't that crazy? It's huge. We can also make sure that we save energy at home, not wasting energy. There's all kinds of programs that different governments, state, or cities have to help us save energy in our home. Eating meat, especially red meat, often has a lot of carbon associated with it, because if you're eating beef, you have to grow the corn, you have to process the corn, you have to give the corn to the cows, you have to grow the cows, you have to kill them, you have to process them, you have to transport it to people's homes or stores. And so there's eating less meat is a good way to do it too. And then you could take public transportation because you're all together in the same vehicle instead of your own vehicle. There's a lot of good ideas, and one of my favorite websites, many of my favorite websites I should say, are websites that tell schools what to do. There's the Green Schools Alliance as an example. There's also Green Schools, and then there's Project Learning Tree that has a Green Schools program. So if your school is not part of one of these programs, sign up, because they have tons of good ideas of ways that you can reduce your carbon footprint at school. If you're looking for ways that your family can reduce your carbon footprint, then I recommend Climate Caretakers. Climate Caretakers is a website that sends you an idea every month, and it tells you the impact that everybody at Climate Caretakers has working together. If you've already done that idea, they send you 2 more just in case you need new ones. Now, there's some ways that we can't reduce our carbon. So for example, I travel a lot. I go to a lot of scientific meetings and conferences, and so I have to take an airplane. Now, they've already done airplane flights using algae biofuel. So that's basically airplane fuel made out of algae. It's green. But they don't do that yet in the United States. They do it more in Europe. So when I travel, what I do is I calculate how much carbon my trip costs, and I donate it to an organization like TerraPath or Climate Stewards, where they take that money and they invest it. For example, in Ghana or Kenya or Mexico, helping plant trees that suck carbon dioxide out of the atmosphere, helping people stop burning down trees, giving them solar cook stoves. Projects that take the same amount of carbon away that I put in from flying. We can also work together in our community. This is a really cool example of a church in Maryland who teamed up with all the people in their community to help put solar panels on the church roof to give energy not just to the church, but to people in their community, because the church has a big roof. It's a lot cheaper to put one big array on a big roof than it is to put a bunch of little roofs on little solar arrays on people's houses. We can also support cool technology too. Like this is a bike path they're putting in Holland in the Netherlands. The bike path is solar panels. Isn't that cool? The whole bike path is made of solar panels. And the last thing we need to do, and especially as a young person, is we need to start making our voices heard. Because we need our decision makers, the people we start to vote for when we're old enough, we need them to understand that this is a serious issue, but that there's good solutions we can do too. And so that's why one of the organizations I volunteer with is Citizens Climate Lobby, because they spend so much time going and meeting with all of our elected leaders and officials in cities and states and provinces and at the national level too, telling them, hey, we care about this. Let's fix it together. Because if you ask people around the United States, for example, do you support funding research into renewable energy? Well, guess what? Just about everybody does. These colors, as you can see here, these colors are 70, 80, even 90% of people support funding research into renewable energy. Slightly less, but still more than 50%, about 55, 60, 70% of people support making our electricity companies produce at least 20% of their energy from renewable sources. This is a picture from where I live in Texas, where we're seeing white wind turbines replacing old oil rigs. Because we have so much wind, we hardly know what to do with it. At night, when people aren't using much electricity these days, the price of wind in Texas sometimes goes negative. In other words, we have so much that the companies running the wind turbines have to actually pay to put it on the grid. They're not just giving it away for free, they're actually saying, we'll pay you to take it. Isn't that crazy? But did you know that China is producing way more wind energy than the United States? This is an old figure from 3 years ago. Now China has almost double the wind energy of the United States, and much more solar energy too. So it isn't just a case of the United States should be doing stuff. Every other country is already doing stuff too, and China is way out ahead on that. Even though whenever we see a picture of China, we're not looking at their wind turbines, we're not looking at their solar panels, we're always looking at their dirty air quality in Beijing. Well, they know it's dirty, and that's why they're getting rid of it. Here in Texas, we have a little town called Georgetown that went 100% renewable last year. And you know why? They said we went renewable, we waved goodbye to fossil fuels, because it was a price decision. It was the cheapest thing for us to do. Isn't that crazy? And this was an article in a Bloomberg Business last year that said fossil fuels just lost the race against renewables. Isn't that crazy? Why did they say that? Because the world is now adding more renewable energy every year than coal, gas, and oil put together. And there's no going back. That is pretty cool. So yes, we can reduce our carbon emissions and we can invest in a new clean energy economy. And it's not just something we do here in the United States. This is a solar panel on a thatched roof hut in Africa. It's something that we can do everywhere to give people clean and ultimately free energy. So this is the way I like to end. What if this whole climate change thing is a big hoax and we create a better world for nothing? What if we create energy independence and clean air and clean water and lots of good jobs and all this cool stuff? That would be an awesome future. So there's many, many reasons to do all these good things because of climate change, because of the polar bears, but also because of us. Thank you. Now, I can't hear anybody, but does anybody have questions that you want to type in? Yes, you can ask questions now. I should say too that if you go to my website, I have a lot of resources there. I have a TEDx talk I gave last year. I have a lot of other little videos and essays. I actually helped to write the grade 10 climate change curriculum for a couple of provinces in Canada. I should post that probably on my website. And I also have a Facebook page and I have a Twitter account. And so I post a lot of stuff if you're interested in following up. So please do check out my website. You can like my page or you can follow me on Twitter. And that's a great way to keep on getting more information about this. Okay, so any questions? Can we use carbon dioxide to power factories? We cannot. Carbon dioxide is what comes out, not what goes in. But what we can use carbon dioxide for is we can use it as plant food, specifically algae food. So they have a couple of experimental power plants in New Mexico, and I think they might have one in Mexico also, where they're burning coal or gas, and it's turning it into carbon dioxide. But instead of letting the carbon dioxide out into the atmosphere, what they're doing is they're piping the carbon dioxide directly into giant bags of green-blue algae. The algae eats the carbon dioxide and grows, and then they can turn the algae into clean biofuel to run cars or airplanes. They've even run tests on airplanes, and it turns out that you don't even have to modify the engine at all. You can take a normal airplane, and you can put algae bio oil into it, and it runs 15% more efficient, which is really cool. Do I think wind turbines will become even more prevalent? I absolutely do. Because if you check the news, you can see that China just got approval for the biggest wind farm so far. If you look at how much wind energy is increasing, I mean, it is exponential. It's not even linear. So yes, we are going to see a ton more wind turbines all the time. And the coolest thing is, for example, in Texas, is that when it's windy on the coast, it's usually not windy inland. And when it's windy inland, it's not windy on the coast. So you can get wind from different parts of the state and different parts of the country. But there's a good question here about how do solar panels work at night? The answer is they don't work at night, unless you're up in the Arctic and it's summer and then the sun is still shining in the summer. How they work, though, is they store energy in batteries. And that is really the biggest issue right now, is building big enough and cheap enough batteries to save all that energy. So Elon Musk, I don't know if you've heard of him, but he's famous for developing the SpaceX program. Elon Musk has invented this power wall that you can put in your own home for $3,500, which is not that much. And it will store all your energy if you have solar panels, or if you just want to buy it from the grid, it will store energy for you. They're doing experiments where they can look at storing energy in refrigerators, and they're building giant big batteries by solar arrays and solar farms to try to save that energy at night. Okay, let me page up here so I can see if I missed any questions. Okay. Are fish affected by climate change? Yes, fish are affected by climate change. Fish and marine species are moving north quite quickly. What's really affected, though, is what's at the base of the food chain. So plankton, zooplankton, phytoplankton, those are being affected most because, first of all, they're moving the quickest as ocean temperatures change, but also they're being affected by the fact that the majority of the carbon dioxide we put into the atmosphere, about 40% stays up in the atmosphere. That's our extra blanket that we're wrapping around the planet. But about 60% of that carbon dioxide is going into the ocean, where it's making ocean waters more acidic. And so some of the biggest impacts we're seeing in the ocean are not only from warming temperatures, but it's also from the fact that the ocean is becoming more acidic because it's absorbing all that carbon dioxide. So that's pretty serious because we're looking at the base of the food chain being affected by that. How much does it cost to install solar panels? Well, first of all, the answer is it costs less and less every year, number one. Second is there usually are some pretty big rebates that the solar installers in your area will know about. So they could be city rebates, they could be state rebates, or they could be federal rebates. Third, there's even some installers, I know of one at least in Maryland, I'm not sure about Illinois, there's some installers where what they will do is they will rent you or they will lease you the solar panels for the price of your electricity bill until you've bought them off. So in other words, you just keep on paying your electricity normally until you've paid off the solar panels, and then it's all free. So for a given home, I'm going to guess, depending on rebates and on the package, if you're actually going to pay it all up front, it might be, I don't know, $15,000 to $20,000 if you're paying it all up front. But there's lots of different ways you can do it, some of which just involve paying a bill every month, some of which involve rebates, and then schools can even apply for grants. So you can apply for grants that will cover your costs. I don't know which specific ones are available right now, but I imagine green schools will probably know about that. Okay. Are renewable energies cheaper and more convenient? They are getting cheaper. So in Texas now at night, wind energy is often cheaper than other types. The city of Austin just signed a new contract for their energy that was all solar because it was the cheapest contract they were offered. So renewable energies are very comparable right now to fossil fuels, and they're getting cheaper and cheaper every year. Of course, also renewables don't produce carbon dioxide. So even if they're the same price, we would rather pick renewables than pick fossil fuels because fossil fuels produce carbon dioxide and renewables don't. What are some other ways to get rid of carbon dioxide? One big way is to plant trees because trees take up carbon dioxide as they grow. But they're also doing really cool technology with artificial trees or giant fans that absorb carbon dioxide as the wind blows through them. So if you Google something like that, like if you Google giant fans or artificial trees and carbon dioxide, you'll see all kinds of cool technologies that people are looking at to suck it out of the atmosphere. But of course, the easiest thing to do is not to put it in the atmosphere to begin with. I have been reading a lot about carbon sink technology on a grand scale. Is there one that seems more promising? The tough thing is that there's only so much you can do with each option. Like there's only so much land where we can plant trees. There's only so much carbon dioxide we can take out of the atmosphere. So really, the most promising thing to do is to produce less carbon dioxide, because the less we produce, then the greater the chance of all of these different technologies have to kind of keep up with us. Any other questions? I don't see anybody else typing. Oh, no, I do see a couple people typing. Okay, you're very welcome. If you have any more questions, again, I often have a lot of questions that I answer on my Facebook page. Skeptical Science is a great resource if you're looking for more science answers. And a couple of the other resources like Green Schools and all that will have a lot more information specific to schools. So thank you, everybody. Mhm. Thank you.